All right, so the fifth section here, solve and graph the solution, but we've got a compound absolute value inequality. So we've got a lot going on here. I'm going to write this kind of two different ways. One is that, hey, what if the stuff inside the absolute value is in fact positive? And so we just kind of deal with it straightforward. Normally we've broken up with a positive and a negative, but we're going to run out of room if we do that. Now it's still the same idea, but just doing one at a time because there is a lot going on these problems. So if this value is positive, then 2 is less than or equal to x minus 6, which is less than or equal to 5. I want to get x all by itself, and so to all three parts here of my inequality, I'm going to add 6. And you may have seen this also written when you split it up into two separate inequalities, which would be 2 is less than or equal to x minus 6, and then also x minus 6 is less than or equal to 5. And then you can see here we're doing really the same steps. You would add 6 to both sides. But these parts right here are the same thing, and so we're actually just keeping it all together, which may or may not be easier for you. Whichever one you prefer out of those two methods, go for it. That's perfectly okay. I'm going to stick with this one, just a little bit less writing. So I end up with 8 is less than or equal to x, which is less than or equal to 11. And let's graph that first off. Over here we've got 0, negative numbers, positive. Actually, let me move 0 over a little bit because we're going to run out of room here. So negative numbers, positive numbers, I'll have 0 off to the side a little bit. And we're going to have 1, 2, 3, 4, moving on up to 8. And now it's the numbers at 8 are going to be, or 8 itself is a solution. It's a filled in because it's or equal to, and it goes up to 11. And 11 is also included in our solution set. Those numbers here, anything between 8 and 11, including 8 and 11, are solutions. 9 would make this true. So 2 is less than or equal to, well, hey, what if we had thrown 9 in here? What's 9 minus 6? That's 3. Absolute value is 3. So, hey, yeah, 3 is greater than 2. And 3 is also less than 5. So, hey, these numbers over here are in fact true. Now, remember, that was just the first part. That was if this was all positive. However, what if it was negative? Then we're going to multiply everything here by that negative 1. And so let's run through that one now. That will give us negative 2 is greater than or equal to x minus 6. Because remember, we assumed that what if this value here was negative? So it's going to kind of turn back to being positive because everything's being multiplied by that negative 1 is also greater than or equal to negative 5. All right, we'll add 6 to all three portions right here and end up with that 4 is greater than or equal to x, which is greater than or equal to 1. All right, let's go graph that now. And I'll graph that one in pink here. So I'm going to go to, it might be easier to think of this kind of in the reverse order. We normally don't have these written here this way. And so, hey, what if I had 1 first? 1 would be less than or equal to x, which would be less than or equal to 4. You don't have to rewrite it that way, but just sometimes that will help folks out. So we have 1, and we have 4. It's not the perfect scale, but you get what's going on here. 1 is included, 4 is included, and those also are solutions. If I had, for example, 2, if I plugged in 2 right now, 2 minus 6 would be negative 4. The absolute value of negative 4 is positive 4, and so 2 is less than or equal to 4, which is less than or equal to 5. All right, let's try that one more time, see if that makes a little bit of sense now. So here's the other problem you had on your notes. And so let's split this up, and again, I'm going to go just with my positive first. You don't have to, but that's, I think, maybe a little bit easier for you. And so if it's positive, then 1 is less than x plus 3, which is less than or equal to 4. I'm going to subtract 3 from all three parts right here and get that what is that, negative 2 is less than x, which is less than or equal to 1. In our graph over here, negative numbers, positive numbers. I'm going to put 0 a little bit over to the side this time. We've got, sorry, 0, here's 1, and here's negative 2. And so my numbers from negative 2, and this time is an open circle. It's not a solution, but up to positive 1, which is a solution. So those numbers there are from the first part. Now on our second one, what if x plus 3 is actually a negative value? So then negative 1 is greater than x plus 3, which is greater than or equal to negative 4. Work our way through, subtract 3 from all three parts, and we have negative 4 is greater than x, which is greater than or equal to negative 7. Again, you don't need to rewrite it, but in case in case that's easier for you, then negative 7 is less than or equal to x, which is less than negative 4. So negative 4 here and negative 7. That negative 7 is a inclusive value. That's the or equals. 4 is not a solution because it's not or equal to. And the numbers here in between are my solutions. So see how we have two different groups of numbers that are going to be solutions for these when we have compound inequalities of absolute values.